In the last video, I finished up all of the machining of the blade with some powerless setups. There was a lot of hand sanding to clean up most of the machining defects. And finally, I did some black oxide testing to see how it would turn out. Personally, I'm happy with how it has gone with the blade so far, so we're moving on to fabricating some other parts of the sword now. Okay, we had a small piece to make this time. You can see what I'm talking about. This is the little eyelet and single chain link that Guts uses to carry the Dragonslayer on his back. Now I'm kind of running out of time on this project, but luckily I was able to source some parts that are very close, and I think I can modify for my purposes. I've got this eye bolt here. This is pretty close, just needs a little bit of shaping. Now underneath the eye bolt is a very thick washer that's sort of got a taper on it. I was able to source these very thick washers that I can kind of like manually shape. As you can see here, the washer is like a slightly higher diameter than the eyelet at the end here. I would say that's a pretty good match. Last bit is the chain link. I kind of went through my scrap pile and I found this. You can see it's about the diameter of the washer, and that's pretty close. We've got the general proportions. I'll just have to cut this chain link off. I'll leave the slit. As you can see, it's not like welded back together. I guess Godot doesn't have, a MIG welder hanging around, so I'll have to pay attention to that detail, but this is a really good start, I think. First things first, I figure the simplest thing is that washer. All it needs is just a little bit of a tapered edge, and all I'm gonna do is this. If you've seen this channel before, you've seen me use this method. Basically, I've got a bolt through the washer with a nut backing it up, and I'm gonna use this drill to spin it against a belt sander, so I can just kind of manually shape that edge so it's just more of a radius than it is just a square edge. Should be pretty simple, hopefully. Not too shabby, I would say. I got that taper, whatever, radius edged. Pretty much exactly how I wanted it. Alright, so that turned out pretty well. As you can see here, there's a little ring at the top. That's where the bolt head was covering the washer, and I wasn't able to sand and polish that part. Wasn't sure how bad it would look, but I'd say that's fairly noticeable. So I tried a few different methods of holding this washer, but nothing I had really worked quite the way I wanted it to, so I just used some super glue and glued it to this cutoff here. This is actually the end of the handle. I had some excess material, and it ended up being almost exactly the right diameter, so here we are. That's on there pretty good. I've also used my glue gun in the past for jobs like this, but I can't find it, so super glue it is. Alright, that's much better. You'll notice I ditched the polished look, even though I spent forever getting it perfect. I kind of like slept on it a little bit, and I realized that nothing on this sword would really be highly polished and beautiful. This is, still very nice, but it's more of a satin finish. I think that'll do just fine. Same sort of idea here, that satiny Scotch-Brite type finish. This was way more work than I anticipated. The eyelet was very rough, kind of like as forged, and took quite a bit of sanding and shaping it to get it to where it is now. Like these areas under here, like right between the washer and the eye, it's just kind of a really tough spots of sand, but I think it came out okay. I also gave it a kind of a slight radius. It's not perfectly square. Looks just about the way I wanted it. Let's work on that chain link now. Alright, so normally I would use a bunch of heat to twist this chain link and get it off the rest, but this is galvanized chain, which is a zinc coating, and vaporizing zinc can be extremely hazardous to your health. So I made a little slit with a bandsaw there on that link, and I'm going to try to bend it cold with my biggest wrench, so hopefully this goes a little easier. Yeah, what do you think? That actually wasn't that bad. Just got a minor cramp in my abs, but what are you gonna do? I'm old. Alright, I just kind of hand sanded the weld off of that chain link, so it's just kind of a cleaner appearance, I guess. Yes? Can I help you? What do you think, girl? Now, I have discovered a problem, and I did sort of anticipate this. Let's see if I can do this with one hand, but as you can see, there's plenty of clearance in there. However, when you try to turn the corner, I can't pass it through there. It's kind of jamming up. What I'm going to do is I'm going to clearance the outside portion of the hole on both sides, kind of give it a taper so that there'll be just enough clearance so this can round the corner. So it needs to be down here, right? And I can't get it all the way on, so that's what we'll have to do. Alright, one last step before we put this chain link on that. I want to get rid of that galvanized coating, so I'm just going to stick it in some vinegar, probably overnight or so. That should get it off. I seem to remember it will, but I guess I'll find out tomorrow. Alright, it's been about 24 hours. Let's go fishing here. And let's see what we got. I'll hit this with a little Scotch-Brite first. Merry Christmas, by the way. Alright, there we have it. Scotch-Brite it off. I'd say it looks pretty good. I think it's a good match color and texture wise for the rest of the pieces. Guess I'll close up that link and call that part done. Not bad looking if I say so myself. Alright, this may seem a little silly, but after reviewing the footage, I thought the eye of this eye bolt was sitting a little high. So I trimmed the shaft down so the washer sits higher. Probably about 1/4 of an inch. I think it looks better now. I realize it's a bit silly, but what part of this project isn't silly? Okay, so the next piece is going to be the handguard. Now, if you're familiar with Berserk or with this sword, you'll know that there's a half moon guard on this thing. It kind of looks like that. You know what? If I'm really smart, when I edit this video, I'll put up a picture of it on the screen. Amazing. So my goal here is to make it out of this thing. I had the local steel supply shop cut me a slice of 1-inch plate. They just plasma cut it in a nice circle. It is oversized, as you can see. It's sticking off the edges here a little bit. Not very much, actually. Yeah, good enough. Basically, I'm going to machine this perfectly round. I'm going to put the groove in it as well, and then I'm going to chop the thing perfectly in half, and then I'll use, you know, each half for each side of the sword so that they will be perfectly symmetrical. Now, in the manga, the half moon guard basically stops right at the edge of the bevel on both sides, and that's why I had to sand these bevels before I did this part, so I know exactly how wide the center strip is, and then I can determine what the diameter of this thing should be. We're actually pretty close, because we're right there, here, and I mean, I don't know if you can really see that, but we're not more than maybe an 1/8 of an inch off on that side. So I'll do some careful measuring, and then we'll head over to the milling machine. I'm actually going to use this guy again. I have finally gotten it working. In the earlier parts of the video, this machine had broken down. It had a major mechanical problem, and then when I took it apart, I discovered 2 more major mechanical problems. When I finally got it all back together after months, I powered the machine on, and it ran for like 10 seconds, and then there was a loud pop, and the machine has never run since. As far as I can tell, the machine was hack job wired. If you look down there on that plate, there was a huge electrical box of all sorts of like homemade electronics, some variable frequency drives and some controllers and everything, and like dozens and dozens of wires. It was this huge nightmare, and I couldn't get a hold of the previous owner to see, you know, what on earth he had done, so I just ripped it all off, and I started from scratch. So I've got a magnetic starter for the main motor, I've got a variable frequency drive for the motor up there, and I just got some kind of like hack job controls up here. This is like the previous guy's work, but I removed some of the buttons, I rewired some of them, I added my own. You can see there's a million wires in there. I basically just kind of left everything there. I repurposed some of the wires for my own stuff, and I just left the rest of it alone. I just wanted to get this machine up and running as fast as possible. I'm running into a deadline problem, so I just need to get this thing working for now. I gotta get this vertical head aligned up so it's nice and straight up and down, left to right and everything. I'm gonna put a rotary table on the machine to do all the milling, and we'll see how it goes. I have not even tested this machine since I got it rewired, so fingers crossed. Jesus. Yeah. God, how damn heavy that thing is. Okay, we are making some progress here. I've got my rotary table set up here. I've got it clamped down. I've got my workpiece. What I'm gonna do is, to mill the outside of this, I'm just gonna remove one clamp at a time. You know, mill this section, replace the clamp, take that one off, mill this section, you know, so on and so forth. So there will always be 3 clamps holding it down. I figured this is the easiest way to do this. Ideally, you would do this in a lathe, I suppose, but my little lathe cannot hold a piece this big, and my big lathe is it's over there holding up that fan. It's not even powered yet. I've never even run it before, so still a lot of work to do on that thing. Honestly, it would still be complicated because the truck would be holding it from the outside, so I'd have to like hold it from like the bottom, you know, and then turn half of it and then flip it around in the jaws, I guess, and try to make it perfect, which would be just a gigantic pain. You know, I guess not really any more or less of a pain than constantly swapping out these clamps, but anyway, if you've never seen one of these, all you do is turn that handle and it rotates the table in a predictable manner. There's all kinds of markings on here. You can do, you know, different degree increments and so forth. I have my ingenious powered setup here, you know. You get the idea. Now, half the trouble with these tables is trying to dial in this workpiece so that it's actually centered. And the problem is, this is not round. It's not even slightly round. So what I've done is I've set up my little laser here, and I kind of got it close to the edge, and then I just, you know, rotated the piece full revolution, and then saw where it was kind of off, and just, you know, tapped it a little bit one way or the other, because there's no real way of measuring it easily because the edge is so rough. And because it is so out of round, it's just kind of like, the edge of it goes in and out constantly. So here, I'll turn out the light and I'll just show you what I mean real quick. All right, I don't know how visible this is gonna be on camera, but the laser is like right there. Now if I rotate it, as you can see, it's not perfect, but I think I'm close enough. This wouldn't be such a big deal, except the diameter of this is actually very close to what I need. It's about 200 thousandths of an inch off. That's only 5 millimeters. So I need to take off, you know, less than 1/8 of an inch off the radius, basically. That's not much. That's actually pretty close to what that gap is. So hopefully this works out. I guess I should have ordered a larger piece of material, but too late now. All right, well, I have no idea how this is gonna go. Wish me luck. The nice thing is I'm actually standing on the other side of the cutter here, and I can't really see what I'm doing, but I can use the camera's viewfinder to see what's happening. That's pretty nice. Alright, so I've made one revolution. It looks pretty good. The only problem is when I was measuring it, it seems like the sides of this are not perpendicular to the surface. The far end is touching down there, but there's a gap here. That's a pretty decent gap. At first I thought maybe the table itself, the rotary table, was kind of like kicked up at an angle. You know, there was something under one end of it that was causing it to, you know, just be angled slightly, but I have ruled that out. I thought maybe the milling machine table underneath the rotary table was sagging or something. I mean, I did have the machine completely apart for like months at a time, so maybe I misadjusted something, but everything seems fine. So I'm guessing the head is tilted this way. So for giggles, I checked the protractor on the side of the machine here. This controls the head, you know, tilt side to side. I don't know if you can really see, this is really old. It's hard to see in the viewfinder, but the 0 on the left and the 0 on the right, they're very close. I'd say that's off by maybe 1/4 of a degree. Honestly, that's fairly typical. You know, you usually just use the protractor to get close, and then you would use some sort of precise measuring instrument to actually dial in everything perfectly. I'm not really sure. I guess I'm just gonna have to strip down this whole entire setup that I just did and loosen up all the bolts and re-measure everything. Maybe I made a mistake. Maybe the head got knocked out of alignment once I started milling. Maybe it was kind of like bound up. You know, I had the bolts really tight, but everything was bound up, and then when I started milling it just shifted, you know, a degree or 3. I'm not really sure, but I'll see you in a few hours. All right, so I decided to do a little sanity checking here. I have this digital level, not the world's most accurate thing, but it's pretty close, honestly. I would trust it within 1/10 of a degree. So if I zero this out on the table, okay, and then I'll take it over here. It's still 0, so I know the rotary table is level. And let's stick this over here. The workpiece is level. And now if I take it, end mills are usually pretty decently perfect. And you can see it should be 90 degrees, off by almost 1 degree. Even if I put it on this cap is machined, it's not perfect, but it's showing. How about the spindle itself? Hard to say. It's actually much closer that way, but think the outside of this is probably not the world's most accurate thing. I don't know, very strange. I guess I'm gonna tear this down. Alright, so I figured out the issue with the head being out of alignment here, and honestly I feel really stupid and really surprised that this hasn't happened to me before. I'll do my best to explain here. This little tool basically accurately shows me how close the head is in alignment. Each of these two indicators should be equal. They should give the same reading if the head is perfectly aligned, right? You know, the plunger is depressed the same amount on both sides, therefore the head is perfectly level. Now these indicators are in graduations of 1/1000th of an inch, so this is a quite accurate setup. Now I've already fixed this side. You can see this one's showing about 3/1000ths. That one is showing 3/1000ths as well. That's actually almost perfect. If I can get it, yeah, like that. Normally you'd be testing right against the table itself. You don't want to introduce more error with one of these. Problem is this table is 84 years old and it has, you know, multiple lifetimes of pockmarks and abuse on it. So I use this ring to kind of even everything out and give me a nice flat surface to, you know, measure against. And you can see it is quite flat. If I move this around, those indicators really don't move, so I'm not getting any sort of deviation at all. Now, as mentioned, I've already fixed this, so it's difficult to show you what I did, but I also discovered that the head is off going in and out for exactly the same reason, so I'll demonstrate right now. Turn this guy 90 degrees, so we're perpendicular to the table. Okay, so left side we've got, what's that, about 49, just under 49. And the other one we're showing, that's just about 48, just over 48. So pretty close, less than 1/1000th of an inch between that side and that side. That's not terrible. But the head is out of alignment still, so how did that happen? The answer is, if you look closely at these stems and how much they are extended, the right side is extended further than the left. It may not be that obvious on camera. It's really not obvious in person either, to be clear. What has happened here is a full sweep of one of these gauges is only 0.1 inches. And that's what's happened, is one of these is sticking out 0.1 inches more than the other. So they actually ended up on the same reading, but one is off by a full revolution. It was really only noticeable when I was doing it the other way, and I had these plungers depressed all the way, and so the difference was immediately apparent, and I realized what I had screwed up. Furthermore, as I turn it, if I watch the gauges, they are actually rotating the opposite direction, and they both end up at the same place again, but they went the other way from each other to get there. That's so now, this is actually how it's supposed to be. It was off by a full revolution when I had it the other way, perpendicular to how it is now. So, yeah, it took me a little while to catch that, but I can't believe I made the mistake twice in two different directions for the first time ever, if that makes any sense. What's also interesting here is if you look at the protractor on the side of the head, we've got our 0 here, and before we were off in the other direction, and now we're off going up, I guess. It actually looks like it's 1 degree off, but it is actually perfect now. Before it was closer, so I thought it was fine, but it turned out I was wrong. And if we come around to the front of the machine here, again, I don't know how well you can see this, we got 0 here, and then the 0 on the head is actually down below by over 1 degree. It's about 1.5 degrees off. So, again, it's in the ballpark. It wasn't immediately obvious that was a problem, but I believe the head needs to come out towards us, you know, enough to make one revolution of the dials and get them, you know, squared away more or less. I'll show you in a second what I mean. All right, I got this realigned. Let's see where we are now. We got just under 2, I would say, and just under 2 here. That's basically perfect. And now when I rotate it, hey, look at that, the gauges aren't moving at all the way it should be. So what do I got here now? I've got a little over 1 and just under 2. So we're off very slightly. That's less than 1/1000th of an inch of deviation. I'm calling that good just based on the fact that this table is definitely not even close to perfect in the first place. And I'm introducing extra error with this thing, so chasing perfection is just, it's kind of pointless and ridiculous at this point. And furthermore, what happens is when you align it in one direction, it kind of tends to throw off the other one, and then when you fix the other one, it throws off the first one slightly. Even the order of torquing these nuts has to be correct, or it can throw it off as you're tightening it. So it's such a delicate operation. I'm calling, you know, perfect in one direction and less than 1/1000th of an inch in deviation the other way is good enough. All right, let's tear down this whole setup and get the rotary table back in there, get everything dialed back in, and let's get back to milling the thing. All right, so we've just made one revolution. I basically trued the whole thing up. This is the second to last cut, as we are actually only 43/1000th of an inch oversized at this point. That's just over 1 millimeter, so one more pass and we're there. I did, however, want to make sure that we're cutting straight. So let's see, I'm trying to line up the camera here. I think you could see that. Yeah, that is nice and straight now. Thank God. Alright, so I heard to be a real YouTuber, you gotta pimp your merch in every single video. So here we are. I paid a really excellent artist to make me some 80s inspired PHM designs, and she gave me 4 of them. I was gonna pick one, but honestly I like them all, so here they are. I got this one right here. I've got this one as well. Very nice. I really like the color scheme on this one, but I think this one's my favorite. It's kind of got like Outrun / Motley Crue vibes. Definitely right in my wheelhouse. Alright, that's it. See you on the next part.